Hello, Algebra 2. This video lesson will explain how to do long division of polynomials from chapter 6.5. And here's the example that I've given you. All I'm going to do in this video is talk you through the guide that I've already handed out in class. So if you already understood the guide, you don't need this video lesson, but if it was at all confusing to you or you just want to refresh your memory, this is why this video is here. So let's say that you were going to try to divide this by 2x minus 1. And step A, rather than step 1. Make sure it's in standard form. So by that I mean both of the expressions are in standard form. And in this case, when I say it already is, I should have said they already are both in standard form. So you can move on to B. I've rewritten up here in gray what the original question was, just to remind you. But B is to rewrite this original question as a long division problem. In other words, write it out so that it looks like long division. Now I've promised that I will try, if I have time, to make a quick video for those of you who've completely forgotten the elementary school lessons about how to do long division of simply of numbers. And if I get to that, I will. But basically, those of you who remember long division are going to find that this process of long division with polynomials follows a lot of the steps you already know. So the first is, of course, you write what you're dividing into the other number on the left. You make this bracket, and here's what's going to be divided. Notice, though, an important point here. If you've got a term that's missing, in other words, if you've got an x degree that you would expect to see if you had all of them represented, but it's not there, leave a placeholder, leave a 0. So as an example here, I've got degree 3. I don't have a degree 2, so I have to put 0 there. Then I do have degree 1, and I do have degree 0. So now that I've gotten all of these represented, and by the way, you may find that you'll have to do something like that on the left here, too. I generally don't on the left, but you may find it helpful. Once we've got that set, we're ready to move on to step C. As I say, above the problem, in other words, you're going to write it up here above the question that you've got, make a fraction. That fraction is going to be the first terms of the numerator and the denominator. Let's go back again and look at the question. The numerator, the first term is 4x cubed. The denominator is 2x. So I've got 4x cubed over 2x. Divide those out. What is 4x cubed divided by 2x? Well, it's 2x squared. Once you've got that divided out, you've divided the top and bottom of that fraction, put your answer, in other words, that 2x squared, as the beginning of your answer to your full question. Your full question, after all, is what's 4x cubed minus 7x plus 8 divided by 2x minus 1? Well, part of that answer is going to be 2x squared. That 2x squared, again, came from looking at this number divided by this number. And where are you going to put this 2x squared? Well, put it in the column that it naturally belongs in. You've got an x squared placeholder here, so put it right above that, 2x squared. Or as I say here, place it directly above the term that has the matching degree. Now we move on to E. What you do here is you multiply this information that you have already, the 2x squared, times all parts of the divisor. So it's going to be 2x squared times 2x, and also 2x squared times minus 1. So 2x squared times 2x is 4x cubed. 2x squared times negative 1 is negative 2x squared. Now you're ready to do subtraction, just like you normally would in long division. So 4x cubed minus 4x cubed, that cancels out, and it should. The first column always, every step of the way, should cancel out. That's why you're doing this. 0x squared minus 2x squared, or in other words, plus 2x squared, is positive 2x squared. Then, as I say here, whoops, didn't mean to do that, bring down the next term from your problem. So it's not just 2x squared, it's 2x squared, bringing this down, minus 7x. Now you're ready to go to the next step. So once again, look at what you have here as your first term, 2x squared. Make that a fraction with this as the denominator. So you've got 2x squared over 2x. And what is that? Well, if you divided 2x squared by 2x, you should get x. Okay, so now x logically belongs in the x column, just like we've been doing before. And you're redoing steps C, D, E, and F. So the next thing to do is going to be to multiply x times 2x minus 1. X times 2x is 2x squared. X times minus 1 is negative x. Then you subtract off all of this from this. 2x squared minus 2x squared is nothing. Negative 7x minus minus, or in other words plus x, is negative 6x. Bring the 8 down, and now you've got one last division process to go through. So once again, you're going to divide this term, negative 6x, over 2x. Well, what's that? That's negative 3. And that's where you got this here. Negative 6x over 2x is negative 3. There's the negative 3 right over the constant column. Negative 3 times 2x minus 1. Well, negative 3 times 2x is negative 6x. Negative 3 times negative 1 is positive 3. And you've got the 6x is canceling, and you've got 8 minus 3, or in other words, 5. At this point, as it says here, repeat until you have nothing left except a remainder. Well, how do you know that this is the remainder? The reason you know this is the remainder is because you have no more spaces over here to fill in. So you've got a remainder of 5. Well, your answer then became 2x squared plus x minus 3, as shown over here, plus your remainder. Your remainder was 5. 5 over 2x minus 1, over the number that you were dividing all along. That's the answer to this. If you have any questions about this still, after already seeing it walked through in class and also watching this video, please don't hesitate to come in and ask me about them. Otherwise, I'm going to assume that you understand long division of polynomials. I will make a separate video about synthetic division.